Okay, first this is a header of this file. Okay, in header normally we'll have file name, author name, module, and module description. Next, the date of the creation, parent module, child module, revision history. Parent module, I think already explained these things. Parent module in the sense that this module where it will going to sit, that module is known as parent module. What I implemented, we can call it as 1.1 version 1.1. The new version we can call it as 1.2. So that is also new version. So date of creation. Okay, first we are going to see about the port list of Amba-AHB RTL. Here I mentioned that global ports, first input ports, next output ports. Okay, it is better to comment each and every ports. Okay, first global ports are H clock and slave clock, H reset n. Okay, this H clock is the common clock. This clock will going to control master, slave, everything, arbiter, each components in AHB. And this SL clock is the local clock for me. My state machine will going to work with reference to this clock. Normally the slave clock is the twice the H clock. Okay, and reset signal. These are all the input ports. Okay, so we know that our normal naming convention is the first word is master, then slave, after the signal name. At last either will going to have I or O. So far we have seen the port list of this Amba-AHB slave RTL. Now, and one more thing here, you can see that the module name and the file name should be same. AHB, this is our convention. Okay, should be same. And the naming convention. Here I included parameter files. Then port declarations. In port declaration you can see each and every signals are parameterized. And then port reg wire declaration, register wire declarations. Okay, thing I implemented for bus T cycles. Then now we are going to see about the state machine. Okay, in that state machine, always at passage of clock or negage of reset n. We know that this kind of coding style indicates what?
This is implementation of sequential block in
sequential block.
Right.
And what kind of reset we are using here? Asynchronous.
Asynchronous reset.
Okay, reset. Okay, here present state, during the reset time present state is S0, else the present state is next state. This next state will be defined in combinational block. Okay, so this sequential block is only for assignment, state assignment, and this sequential block is for output assignment. Outputs only will present here. Okay, so response, reg, all these things. And one more important thing here is we are using slave clock. Our state machine will going to work in slave clock. Okay, all the input signals will come with reference to that H clock. State machine only will going to work in slave clock.
Then what is the frequency of this clock?
The slave clock will be the twice of H clock.
Twice of H clock. Okay.
Okay. And so far we have seen sequential block for state machine, sequential block for output assignments. Okay, now we are going to see about the combo block for that state transition. In that combo block, first I initialized that next state to some known value. Okay, initialization. Next, this is the case statement. Inside that I decoded I am assigning state transitions. if the decoder select signal. Selected means next state is S1, else it will retain in this state only. So if it is in state S1, it will automatically go to state S0 with reference to slave clock. Getting?
What is the use of this block? What process this is doing?
State machine transition. I think about your state diagram. Okay.
Okay. So only two
This is a
states are
state
there.
diagram. Here I used only two states. First one is S0 and second one is S1. Okay.
Okay.
So after the reset, it will come to this S0 state. Okay.
Okay.
Then the based on this decoder signal, from decoder one signal will come, that is H select signal. If this particular slave is selected means it will go to S0, sorry S1. So it will do some process in that S1. After that, when it will come back to this S0, if the passage of slave clock, so during the first clock cycle it will be here, second clock cycle it will be here, and third clock cycle again it will go back to here. This is what my implementation. Okay. Now we are going to see about what is happening inside this state S0. Okay. So what will happen means I will going to draw that like that, right? Slave frequency. Now the master will send all the signals with respect to this H clock. Okay. H clock. For example, H trans. First it has to send H trans. H transfer type. What kind of transfer type? And address. We'll consider only main signals. In order to write some location or read some location, it has to send address master. So address. And if it wants to perform write operation, it has to make this signal as I and write data. Data bus. Okay, 4 signals. Okay. So in first cycle, it will send on address. Address is A. Okay. In second cycle, it may send address A plus 1. Okay. So you just look at here. It is changing its this address with respect to this edge. Okay. Now similarly, these control signals. It wants to perform write operation, right? So this is a 1-bit signal. So it will make this signal as I. Okay. It wants to perform write operation. So the data corresponding to this A location should come in next clock cycle. This is data corresponding to address A. Right? Okay, this is what happening in AHB. In AHB, pipelining operation is happening. We know that one. The data corresponding to first address A will come in the second clock cycle. Okay. So the inputs are coming with respect to H clock. Now my state machine is working with respect to slave clock. Slave clock is twice the frequency of H clock. Okay. Now during this clock period, my state machine will be in S0 state. Okay. So in S0 state, it will process address, write, H write data, all those control signals. It will process all those things. In S1 state, it knows that in next clock cycle the master will going to give the data. Okay. So it will generate one local signal. In next clock cycle it has to receive the data. I have implemented all those things. I will show you in code. Okay. So this is what happening here. If it is read operation means in first clock cycle master will give address, write or read operation, then control signals. In the next clock cycle, slave has to send the data, read data. Okay. So in this clock cycle, it has to put them data. So in first clock cycle, it will be in S0. It will process all those read related control information. In second clock cycle, it will be in S1. Okay. In that S1, it will give that read data. Anyway, outputs are flopped, right? So if we are sending data in this clock cycle means, since we are flopping, we'll get